Hi students, in this video I'll be going through some of the main ideas related to coordinate geometry. Then I'll end off the video by going through a question from the 2018 O-level paper. Right, so let's start off with the first concept. So the midpoint of a line segment. Okay, so the coordinates of the midpoint of a line segment can actually be found very easily. All you need to do is to add up the two x coordinates for the 2 points and divide it by 2, and then you do likewise for the y coordinate. Okay, so for example, if we have 2 points, P and Q, okay, so they lie on a line segment, so let's call this point P and this point Q. Okay, so let's say point P has the coordinates negative 6, 1, and then Q has the coordinates 4, 3. Okay, and we want to find the coordinates of this midpoint. Usually we call it M now. Okay, so we want to find these coordinates. So we can do so very easily by just doing this. Okay, so the x coordinate of P is negative 6. We add it to 4. So negative 6 plus 4 divided by 2. Alright, then we'll do likewise for the y coordinate. 1 plus 3 divided by 2. Right, so that will give us negative 6 plus 4 is a negative 2. Divided by 2, you get negative 1. Then we have 1 plus 3, 4 divided by 2, we have 2. So the coordinates of point M will be negative 1, 2. Right, so we can find the midpoint very easily. So if this is the midpoint, then it also means that these two lengths PM is equals to MQ. Right. Okay, let's move on to the next idea. So the next idea would be the gradient of a line segment. Okay, so we learned from step 2 that gradient is a vertical change over horizontal change, or more commonly known as the rise over run. Okay, so we'll use the same 2 points, let's say P and Q. Okay, so P is here, negative 6, 1. Okay, then Q is over here, 4, 3. Okay, so what do we mean by rise over run? Okay, so in order to identify the rise and run, I need to form a right angle triangle. Okay, over here. Okay, so you know, as you can see, if we want to go from point P to point Q, okay, we need to go to the right. Okay, so we need to go to this point first, and then once we reach this point, okay, let's call this X. Okay, once we reach point X, right, then we need to go up to reach Q. Okay, so when we go up, we call this the rise. Okay, and then when you move horizontally, okay, it's just like you are running around along the ground, right? Okay, that's why we call it the run. Okay, so the gradient of this line, so basically the gradient is a number to measure the steepness of a line. Okay, so it's measure the steepness of a line. Okay, so what we can do to find the gradient is defined as taking the rise. Okay, so the rise will be a certain number. Okay, you divide by the run. Okay, so in this case, let's try to calculate the gradient for this particular 2 points. Okay, this particular line, right? Okay, so let's see the run. Okay, if you are looking for the run, you will focus on the x coordinate over here. Okay, so the x coordinate of P is negative 6. The x coordinate of Q is 4, right? Which means that the x coordinate of this point X over here will also be 4. Okay, because this point X is vertically below Q. If you are vertically below Q, then your x coordinate is the same as Q. Okay, so to go from negative 6 to 4, okay, the run will be a total of how many units? Yeah, it will be a total of 10 units, right? Okay, because you go from negative 6 to 0, okay, 0 may be somewhere around here. Okay, this will be 6 units already. Then from 0 to 4, another 4 units, so total your run will be 10, right? So then let's now think about the rise. So the rise, okay, the y coordinate of x will be the same as the y coordinate of P because they are on the same horizontal level. Okay, so the y coordinate of x will also be 1. Okay, so to go from level 1, okay, just like if you are in a shopping mall, right? To go from level 1 to level 3, you will move up by 2. Okay, so the rise will be 2. Okay, so if we calculate the gradient, then you will get a gradient to be 1/5 or 0.2. Okay, so this is how we can calculate the gradient. Okay, then we also learn that there's a sort of formula to calculate the gradient, but actually it's also still the rise over run. Okay, so the gradient can be calculated using this method by taking y2 minus y1 over x2 minus x1, where x1, y1, x2, y2 are the coordinates of the 2 points respectively. Okay, so let's say we take x1, y1 to be the coordinates for point P. So this will be -6, 1. Okay, then for point Q, it will be 4, 3, right? Okay, so then let's try to calculate this. Okay, so the usual notation that we use is a gradient of PQ, okay, will be equals to, okay, so y2 minus y1. So in this case, y2 is 3, y1 is 1. So 3 minus 1. Then x2 is 4, and x1 is -6, right? So 4 minus 6. Okay, so indeed we end up with the same answer, okay, of 1/5. Okay, so you can use this method to calculate as well, right? Okay, the next one, the concept that we seldom talk about. In general, if theta is the angle of inclination of a line, then the gradient of a line is tangent theta. Okay, so what does this mean? Okay, so we'll use the same 2 points, okay, P over here, and then Q over here. Okay, so Q is 4, 3. Okay. Okay, so basically what they say is that if you draw a horizontal line over here, and this angle of inclination is theta. Okay, then tangent theta will give us the gradient also. Okay, so in order to do trigo ratio, we need to complete this triangle. Okay, so we need to form a right angle triangle. Okay, so we form a right angle triangle. Okay, then if you recall the trigo ratio, okay, for tangent is opposite over adjacent, right? Okay, so as you can see, if the angle that we are interested in is over here, then the opposite side will be here. Okay, then of course the adjacent side is the side that is not the hypotenuse touching the angle. Okay, so this will be A. So as you can see, O now represents the rise, right? Correct? And A represents the run. Okay, so in the end, if you tangent theta will give us a rise over run, okay, which is the same as the initial definition for the gradient, right? So do remember this, okay? So because sometimes the question may tell you that tangent theta equals to 2. So you need to understand that if you are given this, they are also telling you, in other words, that the gradient of that particular line is 2. Okay. Right. So I hope you are following so far. Okay. So let's move on to talk about parallel lines. So in general, if two lines are parallel, okay, then their gradients are equal. Okay. So as mentioned just now, the gradient of a line, okay, is a number to represent the steepness of a line. Okay, so if two lines are parallel, then they should have equal steepness, and hence they should have the same gradient. Okay, so if two lines are parallel, okay, and this one has gradient m1, this one has gradient m2, okay, then m1 should be equals to m2. Okay, so that's a simple idea. Okay, next thing, collinear points. So what will constitute points being collinear? So if 3 points lie on the same line, then they are called collinear points. So what they mean is that if you have 3 points, okay, so if you have P here, Q here, and R over here, okay, so they lie on the same line, then these 3 points are collinear. Okay, so if the question says that 3 points are collinear, then you can actually extract some useful info from it. Okay, because for example, what can we say about the gradient of PQ and the gradient of maybe QR and the gradient of PR? Okay, so if they are collinear, they lie on the same straight line, then their gradient should be equal. Okay, so you can always make use of this relationship to help you to solve problems. All right. So remember, collinear means the points all lie on the same straight line. Okay, next one, perpendicular lines. So in general, for two lines, okay, if they are perpendicular to one another, then the product of their gradient will give you -1. Okay, so if you have a line like this and then another line this way, and they are perpendicular. Okay, so if this is L1, this is L2. Okay, so L1 will have its own gradient, right? So let's call this M1 and M2. Okay, then the relationship between their gradients will be M1 times M2 will be equals to -1. Okay, so this is actually a very useful thing that you'll find that you'll use it very often to solve coordinate geometry questions. Okay, if, let's say I want to find the gradient of line number 2, okay, but I'm not given any coordinates of any points on L2, right? So I can't use y2 minus y1 over x2 minus x1 to find its gradient directly. Okay, but if I can find, or if I know the gradient of a line that is perpendicular to it, then essentially I can use this relationship to find the gradient of M2, right? Okay, so this is for perpendicular lines. Okay, next one will be the equation of a straight line. Okay, so the equation of a straight line, we can use y minus y1. Okay, so y is a general point on the line, and y1 is a particular point on the line. So equals to the gradient times x minus x1. Right, so essentially, if you recall, to find the equation of a line, you will need two pieces of info. Okay, first you need to know the gradient of the line, and secondly, you need to know at least one point on the line. Okay, so let's say we have this line, they want us to find the equation of this line. So we know that there's this point called 4, 2 over here. Okay, so this 4, 2 will be the x1 and the y1, right? So it will be the x1 and y1. And if we know that the gradient of this line is, let's say, gradient equals to half, okay, then we can find then we have enough info to find the equation of the line. So for example, in this, if I'm using this, okay, so y minus y1, so in this case, y1 is 2, will be equals to half, okay, m, right, m is half, x minus x1, okay, so you'll get y minus 2 equals to half x minus 2, so y will be, so in this case, minus 2 plus 2, so this will be the equation of the line, y equals to half x, right? Okay, so of course, you can use the other method also, which is the general form for equation of a straight line is y equals to mx plus c, right? So in this case, you know that m is half, so you can also do it this way. Okay, then all you need to do is sub in the 4, 2, and then you will be able to find c. Okay, so in this case, if you do that, you will find that c is 0 lah. Okay, so when x is 4, y equals to 2. So 2 equals to half times 4 plus c. Okay, so half times 4 is a 2, bring over, so c will be 0. So therefore, your equation on line will be y equals to half x. Okay, so you can also use this method to find the equation of a straight line. Okay, then we'll look through one last concept, I believe, before we do the two more. Okay, before we do the O-level question. Right, so the next one will be the length of a line segment. Okay, so length of a line segment can be found using this. I wouldn't say it's like a formula lah, okay, but it's actually derived from Pythagoras theorem. Okay, so let's say you have point A. Okay, the coordinates is -2, 1, and then you have point B, so you have 4, 9. Okay, so same thing, point A over here, -2, 1, then point B over here, 4, 9. Okay, you want to find the length of this particular line segment. Okay, then we can use this method. Okay, so in this case, this is x1, y1. This is x2, y2. Okay, so we can use x2 minus x1. Okay, so in this case, the length of the line segment AB. Okay, x2 is 4, x1 is -2, so remember, be careful, minus 2, 9 minus 1 squared. Okay, so 4 minus 2 gives you 6, so you have 6 squared plus 8 squared, right? Okay, so 6 squared is 36, 8 squared is 64, add up together you get 100, so you will get 10 units. Okay, so this for you is the length of a line segment, right? Okay, one last concept before we go on to do the O-level question. Okay, so we call this usually we call this the bootlace method or the shoelace method, okay? Okay, because okay, so this particular method is meant to help you to find the area of a polygon. Okay, so polygon is any shape that is 3 or more straight sides. Okay, so you can use this to find the area of a polygon. So it can involve triangles, quadrilaterals of all different types. Okay, it can be a kite. Okay, it can be a trapezium, can be a parallelogram. Okay, but it can be even none of it, like the one below. All right, then it can also be used to find polygons with more than 4 sides. Okay, so how does this one work? Okay, we'll just use this as an example. Okay, so let's say we want to find the area of PQRS. Okay, so area of PQRS. Okay, so basically what you need to do is list down the coordinates in an anti-clockwise manner. Okay, so one recommendation is to start with the coordinates with a 0 inside one. The more zeros, the better. Okay, so this will x coordinate 2, y coordinate is 0. So we will list it this way, 2, 0. Okay, then you need to go in the anti-clockwise manner. So the next one we go to 4, 4. Okay, from 4, 4 we go to 0, 6. Okay, 0, 6 we go to P, there is negative 1, 3. Okay, then you always need to go back to the first point that you started with. Okay, 2, 0. Okay. Okay, so how does this thing work is that it works in actually a simple manner. Okay. Okay, so you will go downwards first, then you will go upwards. So when you go downwards, 2 times 4 will give you 8. So when you go downwards, then it's a positive, okay? Or you are rather adding. Okay, but if you go upwards later, you will see you will start to subtract. So downwards will be 4 times 6 will give you 24. So going downwards, we add. Okay, 0 times 3, so you add 0. Okay, negative 1 times 0, so you add 0 again. Okay, that's why the more zeros, the better. Okay, so start with points that have a 0 in the coordinate. Okay, go up 0 times 4. So remember going up with minus. Okay, 4 times 0, minus 0 again. Okay, this is where you need to be careful. 6 times negative 1. Okay, 6 times negative 1 is negative 6. But if you minus negative 6, anyway, I'll just show the working, then it becomes plus, right? Then this one will be 3 times 2, which is already positive 6. So you just minus positive 6. Okay, so just simplify the things inside. Okay, so 8 plus 24, you get 32. Okay, over here you have a plus 6 minus 6, so this becomes 0. So in the end, actually, we are just left with 32. So half times 32 will give you 16. Okay, 16 square units, right? Right, so you can apply this to find the area of polygon. Okay. Okay, let's move on to this O-level question. Okay, so O-level questions related to coordinate geometry I would say are usually the more challenging type of questions now, okay, as compared to other topics. Okay, but if you analyze the question properly, you should be able to do it. Okay, okay, so this is the 2018 paper 1 question 9. Okay, so let's read the question. So the diagram shows a kite OABC, okay, in which OA equals to AB. Okay, so they have already drawn it inside a diagram for you already. Okay, OA equals to AB, OC equals to BC. Okay, given that the coordinates of A and C are 0, 10 and 5, 0, 5, 0 and 0, 10 respectively, find the equation of OB. Okay, so they want the equation of this line OB. Okay, so remember what I mentioned earlier. In order to find the equation of a line, you need to know two things. Okay, first you need to know the gradient of OB. Okay, gradient of OB. Okay, so let's call this MOB now. Okay, and secondly, you need to know one point on OB. Okay, so if you ask yourself this question, do we know any of this info or not? Okay, gradient of OB, do we know? Okay, this one we don't know, right? Okay, there's no info given to us. Okay, we don't know, we can't tell. Okay, in the question they didn't mention. Okay, the next thing, okay, do we know one point on OB or not? Okay, so look at OB. What point does it passes through? It passes through B. Okay, but we are not told the coordinates of B, so definitely we don't know the coordinate of B. But what other point does it pass through? Yeah, it passes through the origin, right? Okay, and the coordinates of the origin is 0, 0. So we know this already. We just don't know the gradient of OB. So if we know the gradient of OB, then we will be able to find the equation of the line OB. Okay, so let's see how we can find the equation of line OB. Okay, so if you look at the diagram, okay, are there any perpendicular lines? Okay, so if you think about it, for this one, you will need to know the property of a kite. So if you don't know the property of kite, then you will not be able to solve this question successfully. So for kite, the two diagonals, so OB is one diagonal, and AC, right, they are perpendicular to one another. Right? Okay, and can we make use of this to find the gradient of OB? Okay, yes, we can, right? Because we know the coordinates of C, we know the coordinates of A, we will be able to find the gradient of the line AC. And once we find the gradient of line AC, okay, remember what is the relationship between the gradients of perpendicular lines? Yeah, their product is -1, and that will allow us to find the gradient of OB, okay, which is the only info that we are lacking. Okay, so this is the way you analyze the question. Okay, you write down what are the things that you need and what are the things that you already have. Okay, and then you try to go about thinking how you can find those things that you don't have. Okay, that will help you to solve the question, right? Okay, so if you are able to internalize this sequence of thinking, then it will be able to help you to analyze the question in a calm and sequential way. Okay. Okay, so let's take a look at the equation of okay, let's find the gradient of AC first, right? Which is what we need. Okay, so gradient of AC. Okay, so it'll be y2 minus y1. Okay, so let's use point C to be x2 and y2. Okay, so it will be 10 minus 0 over 0 minus 5. Okay, that will give us -2. And indeed, we know we are right because AC is a line that is sloping downwards, so it should have a negative gradient. Okay, then we can find the gradient of OB already, right? So gradient of OB times gradient of AC, which is -2, will give us -1, right? Because OB is perpendicular to AC. Okay, so this will give us gradient of OB equals to half. Okay, indeed, we are correct. We know that we are on the right track because OB is going upwards. Okay, so it's going upwards from left to right. So the gradient should be positive. Okay, so now that we know the gradient of OB, then we know it passes through 0, 0. We can find the equation easily. Okay, if you are familiar with this, 0, 0 means the y-intercept is 0. So technically, you can straight away write out the equation of OB is y equals to half x. Okay, but for those of you who are not familiar, yeah, then we can use remember what we learned just now, y minus y1 equals to m x minus x1. Okay, but in this case, x1, y1 is 0, 0. Okay, so y minus 0. Okay, so maybe we write here equation of OB. Okay, will be y minus 0 equals to m x minus 0. Okay, so y will be equals to half x. Okay, so this will be the answer for part 1, right? So the equation of this line. Okay, so usually I like to write the equation parallel to the line. Okay, so like this. Okay, will be y equals to half x. Okay, let's look at part B. Okay, so actually not a difficult question for 3 marks over here. Okay, they want us to find the part 2. They want us to find what is the coordinates of this point B. Okay, so what is the coordinates of this point B? Okay, so if you think about this, there are several things that you can think about. Okay, so point B, if you for the usual coordinate geometry question, point B lies on the line AB, and then it lies on the line BC. Okay, so some of you may be thinking that if I can find the equation of AB and I can find the equation of BC, right, then I can solve simultaneous and get AB. Okay, so at this point you should pause for maybe 1 minute and then you think, okay, can I find the equation of AB? Can I find the equation of BC? In order to find the equation of AB, I need to know its gradient, right? I already know it passes through 50, but can I find the gradient of AB? No. So if you look at this, think about this for a while, there's no way you can find the gradient of AB. You're not given enough information, okay? If we know the coordinates of B, then we can, but now the question is asking us to find the coordinates of B in the first place. Okay, neither can we find the gradient of BC. Okay, so if you think about this, then you abandon the idea of finding the two equations and solving simultaneously. Okay, so the next thing I would like you to think about is you think about this question. What are the info that we don't know yet? Or rather given in the question, but we haven't made use of it yet. Okay, so think about it. What is the info that we have? Okay, but we haven't made use of it yet. Okay, so you see we are given two equal sides, right? OA equals to AB, OC equals to BC, and we haven't made use of this yet. Okay, so now my question to you is this: do we know any of the lengths? That means any of the length means we know the specific value of the length. Okay, so if you can look at it, think about this question, OA, right? We know the length of OA. O is 0, 0, A is 5, 0. This means that OA is 5 units, right? The length is 5 units. OA is 5 units, then AB will also be 5 units. And I know the coordinates of A, right? Okay, so maybe I can think along this line and try to use this info to find the coordinates of B. Okay, so the next thing that I also know is that B lies on the line y equals to half x. Okay, so remember, when a point lies on a line, if I know one of its coordinates, then I can sub it inside the equation and find the other coordinate. Correct? Okay, but now you'll be thinking B, I don't know both of the coordinates. Okay, but remember over here, we have AB equals to 5. So I have information to formulate an equation. And if I have information to formulate an equation, and there's only one unknown in the equation, then I can solve to find the unknown. Right? So basically that is the approach that I'm going to take over here. Okay, so in this question, what I'm going to start off is I'm going to let the coordinate x coordinate of B be B. Alright, I'm going to let the x coordinate of B be B. So if the x coordinate of B, so the equation of OB is half x, right? So if the x coordinate is B, then the y coordinate is what? So when x equals to B, the y coordinate will be half B, right? So now I only have one unknown. I can formulate an equation using this piece of info, and then I can solve for B, and then I'll be able to find the coordinates of point B. Right? So basically that's the approach that I'm going to take. Okay, so do refer to the question inside your 10-year series. Okay. So the first step, okay, we'll let the x coordinates of B coordinate of B be B lah, okay? Okay. So if the x coordinate of B is B, then the y coordinate of B will be equals to half B, right? Okay, so essentially I know the coordinates of B already. With one unknown now, okay? So, and if I can find this value of B, then I essentially solve the question. Okay, so now what we are going to do is we are going to make use of this relationship, right? The length of AB is 5, okay? So to formulate an equation. Okay, so to formulate an equation is a very important skill you need to know in math. Okay, so remember, now b is b half b. Okay, so if you go back to the question, the coordinates of a is 5, 0, right? Okay, so a is 5, 0. Okay, so we are going to make use of this concept that we learn length of line segment. So let's say b is x2, y2. Okay, then this one is x1, y1. Okay, then we will use the formula. Okay, x2 minus x1 squared. Okay, so x2 is b minus 5 squared plus y2 minus y1 squared. So half b minus 0 squared will give us the length of OA, which we can tell easily that is 5, right? So let's solve this equation and then we'll be able to get b. Okay, so we'll square both sides first. Okay, so always simplify. Don't do too many steps at once. Okay, then over here you can see half b minus 0 is just half b. Okay, so this one you can simplify a bit. Okay, you square the right side, you get 25. Okay, then this one will expand. Okay, so b squared minus 10b plus 25 plus 1/4 b squared equals to 25. Alright, so we'll tidy up a bit. Okay, so b squared plus 1/4 b squared, so you'll get 5/4 b squared. Okay, because b squared is 4/4 b squared, right? Plus 1/4 get 5/4. Minus 10b. Okay, the 25 will cancel off. So that's great. Okay. Okay, then from here what I'll do is I'll multiply by 4 throughout. Okay. So you'll get 5b squared minus 40b will be 0. Okay, then we'll continue over here. Okay, then from here we can divide by, okay, either you can divide by 5, yeah, maybe you can divide by 5. So you get b squared minus 8b equals 0. And then to solve this, we'll factorize out the b. Okay, so either b equal to 0 or b minus 8 equals 0. So from here, you'll get b equals to 8. Okay, so obviously, if you look at the question, okay, you get two answers for b, right? The x coordinate of b, b can't be 0. If b is 0, then the x coordinate of b is 0. The y coordinate is also 0. Then b will be the origin. So this answer, you've got to reject it, okay? Okay, because b can't be 0. So in other words, the one b that we want will be this 8. Okay, so therefore, coordinates of b will be, okay, remember b is b and half b, right? So b will be 8, half b will be 4. Okay, so this will be the way that you solve a question like this. Okay, so do try more questions from the CYS or your flat booklet for coordinate geometry. And remember to analyze the question in a sequential way. So I just repeat again. I always ask myself what is the information that I need in order to solve a particular part of the question, and then what is the info that I already have, and then I try to find those info that I don't have, and then hopefully get me closer to solving the question. Right?